Welcome back to the Math Professors. If you're looking for content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Van Hamlin, and we're going to graph some logarithmic functions today. So here's the process. First, we're going to find the x and y intercepts. Then we're going to determine the transformations on the parent function. Now the parent function is going to be the equivalent logarithm with the same base. Now since this is a log base 3, the parent function of this one is going to be equal to y is equal to the log base 3 of x. But in general, we're really looking at y is equal to the log base b of x is going to be our parent function. Again, in this case, it is 3. We need to now determine where the point 1, 0 transforms to through these transformations. Because I know when I plug in the log base b of 1, well, the log base b of 1 is always going to be equal to 0. What we know is exponentials go through the point 0, 1. Logarithms will go through the point 1, 0 prior to being transformed. Now we're going to find their vertical asymptote. Again, similar to your exponential functions, they have horizontal asymptotes. Since your logarithms are inverses, they're going to have vertical asymptotes. And then last, we're going to graph the thing. So let's go ahead and start out with this graph. And what I know is the parent function is going to be equal to f of x is going to be equal to the log base 3 of x. All I know is this thing's been shifted. All right, so step 1. We're going to find the x and y intercepts. Well, the x-intercept happens when y is equal to 0. And then the y-intercept happens when x is equal to 0. When you find an x-intercept, you're going to have to do algebra, and when you find a y-intercept, you're going to have to evaluate. So plug in y equals 0. 0 is equal to the log base 3 of x plus 9 minus 1. And then again, we isolate the most complicated structure here, which is going to be that logarithm. So we're going to add 1 to both sides. 1 is going to be equal to the log base 3 of x plus 9. Now you have choices in order to solve this. It's kind of up to you. You're welcome to turn it into its equivalent exponential function. So base 3 exponent 1 is going to be equal to the argument. Another way I like to do this is the way you get rid of a log base 3 is you're going to exponentiate both sides by 3, which means I'm going to do 3 to the 1, and I'm also going to set this equal to 3 to the log base 3 of x plus 9. Now 3 to the 1 is going to be equal to 3. 3 to the log base 3 of x plus 9, well, the exponential base 3 and the log base 3 are going to cancel, so you're just going to get the argument back. So either way is equivalent. So 3 to the 1 is equal to 3, which means now I can subtract 9, so x is going to be equal to negative 6. So kind of writing our solution points. Now this is the x-intercept, so I have negative 6, comma, well, y was equal to 0. Now let's find the y-intercept. So for the y-intercept, we're just going to plug in x equals 0. So y is going to be equal to the log base 3 of 0 plus 9 minus 1. So this is going to be equal to the log base 3 of just 9 minus 1. Again, there's a couple different ways that you can evaluate this log base 3 of 9. I'm just going to use its inverse property. So what I'm going to do is I'm going to write 9 as a base 3. So y is going to be equal to the log base 3. Well, this 9 here can be rewritten as 3 squared minus 1. We're going to still simplify this before I do anything. So log base 3 and exponential base 3 are inverses, so what's going to give me back is just the exponent, very similar to the property that we did here, except in the other direction. So this is going to be equal to its power minus 1. So 2 minus 1 is going to be equal to 1. So we also have the solution point. Y is equal to 1. And x is equal to 0, so 0, 1. Now what I also want to do is find its transform point. So what I know is, in order to do that, let's look at the transforms. Well, what does this x plus 9 do? What does this minus 1 do to this particular parent function? Let's handle the left and right shifts first, which are going to be operations on x. So x plus 9 means left 9. Now, and minus 1 means I'm going to subtract 1 to the outside of the logarithm, which means I'm going to pull this thing down 1. So now let's look at the point. What I know is the parent function is going to go through the point 1 comma 0, but really what I want to know is what does this function go through, not this one. So we know we're going to have to go left 1, left 9. So subtracting 9 to 1 is going to be negative 8 comma 0. And we're going to have to go down 1. So down 1 is going to subtract 1 from that 0. So this is going to be minus 8 comma minus 1. So then I have another solution point over here. I have minus 8 comma minus 1. 4, we're going to look at the vertical asymptote. Vertical asymptotes happen for logarithms when the argument is equal to 0. So in order to find a vertical asymptote, this happens when this is when the argument is equal to 0. The argument being equal to this piece here. So that's the argument. So this is, this argument is going to be when x plus 9 is equal to 0. So x is going to be equal to minus 9. So another way to think about that is, this parent function is a logarithm that does this. It goes to the point, 1 comma 0, and it's got a vertical asymptote of x is equal to 0. So when I take this function, it doesn't matter if I move it up and down, but when I take it left and right, that's what's going to manipulate that vertical asymptote. So it's got to go left 9. So right now it's at 0. If I go left 9, now it's at negative 9. And then last, we're going to graph. So if I graph this thing, I know I have solution points of negative 6, 0. I have 0, comma 1, and then also negative 8. So it's going to do it down here. So negative 6, 1, 2, 3, 4, 5, 6, 0. So this is going to be 1 point. I have 0, comma 1, which is right here, the y-intercept. I also have negative 8, so negative 7, negative 8, negative 1, so down here, another solution point. And then don't forget that we have a vertical asymptote at negative 9. I'm going to erase that 5 and fix that. So again, remember that the parent function for logarithms are doing this. So this is going to go, we're talking left 9 down 2. So we can see that it looks like this. That is our graph for this logarithm. Again, if you like the content, please consider liking, subscribing, and sharing. Thank you.